Okay, continuing on. Pre-calculus, Module 1, Lesson 17. We're going to finish up with exercises 11 to 13. So let's go ahead and, let's get into it. Z equals -1 plus I, and let W equal 2I. Describe each complex number as a transformation of Z, and then write the number in rectangular form. Okie dokie. So let's go ahead and say Z equals -1 plus I. Actually, you know what? Before we get into this, let's go ahead and do some analysis of the problem. Let's see what it's asking us to do. So let's go ahead and put that away. So describe each complex number as a transformation. So let's describe this first. So we have a number Z, some number Z, and then first thing we're going to do is we are going to reflect Z across the real axis. And then, two, we're going to rotate. Now we're going to start doing the multiplication by W, which is going to involve a rotation and a scaling. So rotate by arg W. And then three, we are going to scale by modulus of W. Okay. And so from that, let's go ahead and prove this. So we are going to have Z, which equals, so this will be part one, Z equals -1 plus I. So then Z bar is going to be -1 minus I, so Z bar being the conjugate. So now I have -1 minus I. So now I've done number one. I've reflected across the x-axis, or the real axis. Number two, let's rotate by arg W. Well, the arg of Z is equal to, well, let's go ahead and look at this. If I'm at -1, +1, I'm right there. I know I have a 45-45 triangle since the coefficients of both the real and imaginary part are the same. So that would be, I am at 1, 2, 3 pi over 4. And the arg of Z bar is going to be equal to, so let's go ahead and reflect this down here. Well, I'm going to add 1, 2, so I'm at 5 pi over 4. Okay, so arg of Z bar equals 5 pi over 4. So let's go ahead and find the argument of W. Well, W is right here at 2I. Oops, let's go ahead and erase that. So when so arg of W equals pi over 2, which I'm just going to put it over 4 so we can have the same thing. 2 pi over 4. And remember whenever I multiply two complex numbers, I add their arguments. So arg of WZ bar is going to be equal to 5 pi over 4 plus 2 pi over 4 for 7 pi over 4. And then modulus of W, so this is all for number 2. And number 3, modulus of W is equal to, well, that's just 2 because it's directly on an axis. So its distance from the origin is just that number since it's on the axis. So then modulus of Z, because I'm just reflecting it and I'm not doing anything, that's going to be the same thing as modulus of Z bar, and that will be equal to -1 squared plus 1 squared root of it all, so root 2. So modulus of WZ bar equals 2 times root 2, so 2 root 2. And let's go ahead, so we've done this. We now know this is the argument, this is the modulus. I can go ahead and write that in polar form. Let's go ahead and do the math real quick. So I've got 2I times -1 minus I. That will be -2I minus 4. Sorry, not minus 4. Minus minus, geez, why am I blanking? We got minus 2i squared, which is going to be the same thing as 2 minus 2i. And there we go. We have it in rectangular form. So let's move on to the next one. There we go. So 1 over z bar. So that was some number w times z bar. Now let's just do 1 divided by z bar. And then I can see that this is going to be 1. I am going to reflect z across real axis. Whoops. Axis 2. And then after we reflect across the real axis, we are going to rotate by 2 pi minus arg z bar. And then 3 scale by 1 over modulus z bar. So let's go ahead and do that. We have z equals -1 plus I. The bar equals -1 minus I. Okay, perfect. And then that's 1. 2 for rotate by 2 pi minus arg z bar. I'm just going to go ahead and borrow what we've already calculated up here as there we go, as argument of z bar being 5 pi minus 4. So I have 2 pi minus 5 pi over 4, giving me 3 pi over 4. And now that I have this 3 pi over 4, let's go ahead and find 1 over z bar, which, that's not erasing. Why are you not erasing? There we go, there we go. Okay, now that I have this 3 pi over 4, we're going to scale by 1 over z bar, and that's just going to be, so again, z bar is right up here, so root 2. So I need to scale by 1 over root 2. And perfect, I've got it all. So I have an argument of 3 pi over 4, and that will be my modulus. So I can go ahead and put that in polar form and then convert, or I can just do this algebraically, 1 over -1 minus I. Let's go ahead and make that a little more obvious. Okay, and that's just going to be 1 over -1 minus I times -1 plus I over -1 plus I, giving me -1 plus I over, and this is just going to be a 2, and that will give me -1 over 2 plus 1 over 2I. Perfect. And for the last one, bar of z plus, or w plus z. Okay, this is just going to be z translated, whoops, that's ugly. Okay, there we go. Translated by another random mark. There we go. And z translated by w. And then reflected across the x-axis, or the real axis. Perfect. So let's go ahead and do that. Now I have -1 plus I, and then that will be added by 2I, giving me -1 plus 3I. And then I'm going to go ahead and reflect that. So that's -1 minus 3I. So this is going to be w plus z is going to equal this. And then this is going to be w plus z all of it bar equals this. Perfect. And that is all for lesson 17. Thank you so much.